Now we are going to talk about the modeling language that is used in software engineering. Now we had talked about how to create classes in the code, like coding, like the first part was mostly coding, right? And we learned how to create classes in Python, right? Now, when you are on your own, it's fine that you, like, with the class that you think about, you can think about and write right away, right? But when you are working in a team, you need to think together and make a decision together and communicate this decision before you start coding. Now, how are you going to communicate that? Sometimes there's multiple teams working together, not just a group of people forming a team. It is possible to have multiple teams, and they need to communicate what needs to go in the code together before the coding starts. Okay, so for that communication, we need some sort of a language, right? Naturally. Now, this language is what we call the modeling language. Now, a modeling language in general, you may have experience working with modeling languages in your engineering discipline, right? Did you? Okay, what modeling language did you work with? Any modeling language they work with? Could be diagramming, like a graphical language, or non-graphical language. So what is modeling in general? What is modeling? Now, when you have a complex system, there are so many aspects of the system that not necessarily are relevant to you. So the model just describes subset of the aspects of the system that are relevant to what you're doing. Okay, so when you describe a system using or create a model for the system, you're not creating the exact system, you're just creating a description of the important aspects for you. Yes.
Would it be like a
Distribution what? Distribution of tasks. So what do you mean by that? No. So this is the management of the project. That's another aspect. Now, let's say we want to create a program, a Python program. Okay, we have a team of 5. Now we need to decide what needs to go to the program, right? And who's gonna do what. So maybe that's what gave you the impression. But okay, who's gonna do what in terms of the program? Let's say we're gonna decide to create 4 classes, and this is how the classes would contain, and this is how they are going to interact with each other. Now that everybody understands, generally speaking, how the system is going to look like, we can divide the tasks. But now, before we can divide the tasks, we need the description. We need this common understanding, right? Now, and for that common understanding, we need a language to communicate. Now, different systems or different aspects of the system can be described with different languages. In software engineering, we have UML. Okay, now there are so many modeling languages. Some of them could be graphical, so described by graph, by diagramming. Some of them could be textual. Okay, the UML is mostly graphical language. So UML, mostly diagrams. Not all diagrams, not all graphical, but it's mostly graphical. Okay. So UML stands for Unified Modeling Language, and this is the language used in software engineering. Now you see here there is a claim that it is a standard, well, it's not a claim, it is a standard language. It is accepted by standardization organizations like the ISO and the OMG. Supposedly, it is the official standard communication language or modeling language in software engineering. However, reality of software engineering is that something that you might need to be emphasized for you particularly, because you are coming from another engineering discipline. And almost every other engineering discipline must follow the standards to the T, right? Now, not following the standards in civil engineering could be serious problems, right? Not following the standards in mechanical engineering is a serious problem, right? Every other engineering discipline, if you don't follow the standards, it could be even legal issues, right? Not in software engineering. So software engineering, because it's a new discipline, the claim to have standards that we have to follow to the T proven to not be efficient. It doesn't work. So in software engineering, rigidity breaks. Because the field itself is very new. And whenever we claim that we have full understanding, we have level of certainty, that we create a standard that we have to follow, reality breaks that. Because it's not like other engineering disciplines. Yeah, we call it software engineering because we're trying to make it as standardized and well established like other engineering disciplines. But it is very, very young. It's very young compared to, like, humanity has thousands of years of build-up experience in civil engineering, for example. Every other engineering discipline may not be as old as civil engineering, but there is lots of accumulated knowledge all over humanity, right? So there is a high level of certainty there. That's why standards work, because they are built on very long experience. And software engineering is a very, very young discipline, and we cannot claim that level of certainty. So trying to follow standards, it just doesn't work. It's just great. Okay, so we don't take it as a standard that you have to follow. We take it as general guidelines, general recommendations, but flexibility is there. We didn't reach the point that we can be that as well established as the other disciplines. Okay, so we're gonna learn about UML because it is commonly used, but it's not that, like, the aspects of it are not that strict. But it's definitely, if we have a common language that we agree on, it makes the communication much easier. So it is definitely a general recommendation. It is important for this course to follow what we're gonna learn, the syntax that we're gonna learn about the language. But when you, like, in the reality in the industry, you don't have to be too rigid about it. Okay. So there are a set of diagrams that are created under the UML language. So why is it called unified modeling language? When the object-oriented programming discipline started to become popular, every group of people would have their own diagramming notations to describe the system. So they looked into these different notations and unified them into this one UML, unified modeling language. Okay, so there are a set of diagrams. The two main categories are structural diagrams and behavior diagrams. So, as we agreed, modeling is just to capture particular aspects. When you create a model, you just capture particular aspects of a complicated system. So every model gives you a view of the system. So when you talk about behavioral diagrams or behavioral models, so these are models that describe the behavior of the system, the interaction between the different components of the system, like steps and stuff like that. When you talk about structural diagrams, these are diagrams that give you or like model these structure aspects, or the different components and the relationships between them, not the interactions, just the static relationships. Okay, so the one that we're going to talk about today is the class diagram. So it represents classes. We know what classes there are. This is the template of objects, right? Now we describe classes and relationships between them using a class diagram. And it's definitely one of the structure diagrams, and it represents static aspects of the system. So this is how the class diagram would look like. The syntax of the class in the diagram looks like this. I think it has 3 sections. The top section is the class name, the middle section a list of attributes, and the last section is the list of methods. Okay, and the negative and positive in front of the attributes and the methods are to represent whether they are private and public. Now, the diagram, the notation of the diagram is to describe the general object-oriented concepts. Not every language is the same. As we discussed, the having a private member in Python is not exactly, it's not properly implemented. Okay, but this is just a notation to describe the concept in general. Okay.